Hello everyone, I am Aditya Sauri. Today our topic is sorting techniques. So in previous videos we already discussed about searching techniques. Now let us discuss sorting techniques. We have so many sorting techniques. Now let us discuss bubble sort. Before going to the topic, what is sorting? So the elements which we have to arrange in an order, in ascending order. For example, if I take 5 elements, we have to arrange these elements in an order, and this concept is called sortings, and we have so many types of sortings. So now let us discuss some of those sorting techniques. So today our topic is bubble sort. In bubble sort method, the list is divided into two sub-lists, sorted and unsorted. The smallest elements is bubble from unsorted sublist. After moving the smallest element, the imaginary wall moves on the element ahead. The bubble sort was originally written to bubble up the highest element in the list. But there is no difference whether highest lowest elements is bubbled. This method is easy to understand but time consuming. In this type, two successive elements are compared and swapping is done. Thus step by step entire array elements are checked. Given a list of n elements, the bubble sort requires up to n-1 passes to sort the data. Okay, in bubble sort we have to compare each and every element. After that, if the condition is okay, no need to swap. If the condition is not satisfied, we have to swap the elements. Now let us take some elements and let us implement the bubble sort technique. Before going to the example, let us see the algorithm for bubble sort. Here we have to compare each pair, that means two elements, of adjacent elements from the beginning of an array, and if they are in reversed order, swap them. If at least one swap has been done, repeat step 1. Here repeat for p equal to 1 to n-1 beginnings. In step 2, repeat j equal to 1 to n-p beginning. In step 3, if a of j less than a of j minus 1, swap a of j and a of j minus 1, and for. And in last, after finishing all the iterations, we have to exit. Now let us take a small example and implement this algorithm. Here I am taking only 4 elements for easy working. Okay, so here I take 77, 43, 51 and 13 elements. Here we have 4 elements, that means n, and we have to do n-1 iterations. So the basic rule is we have to do n-i iterations, not 1. Okay, we have 77, 43, 51 and 13. So in first iteration, let it be called as pass also, in pass 1. So we have to compare 2 elements. So here we can see in algorithm, so compare each pair of adjacent elements. So pair means 2 elements. So let us compare these 2 elements. Here 77 greater than 43. So in sorting order, we have to sort in ascending order. That means the first element must be small, compare it to the next element. So here 77 is largest than second element. So whenever the condition is greater than to the next element, we have to swap those two elements. So we already know what is swapping. So 43, 77, 51, 13. So after finishing this looping, next two elements 77, 51. So here also 77 is greater than 51. So here also we have to swap. So after that, these two elements. So here also same condition. So again we have to swap here. So I already told you we have 4 elements, that means we have to do n minus 1 repetitions, that means 3 iterations. So here the pass 1 is finished. Now we have to go for pass 2. So here also we have to do 3 passes. So at last our values is 43, 51, 13 and 77. So again same logic will be repeated here because we are using looping concepts here. So here the condition is okay. After that we have to do comparison for these two elements. Here the condition is not okay because 51 is greater than 13. So here we have to swap. After that 13 to 77. Okay. Now we have to do comparison to these elements. So 43, 13, 51, 77 because 51 is smaller than 77. So here another pass is finished. Now we have to check for these elements. So we have to do another pass. So here 43 is greater than 13. So we have to swap these two elements 51, 77. After that we have to check for these two elements. Here condition is satisfied. After that in another looping we have to compare these two elements. So here also condition is satisfied. So at last we got 13, 44, 51 and 77. So at last the sorting is finished. So in this way we can arrange elements in sorting order, and in this topic we use it bubble sort. So in bubble sort we have to do sorting in this way only because it is the technique, one of the technique to sort the elements. Now let us discuss another sorting technique called merge sort. So compared to bubble sort, merge sort is used to done very fast, that the arranging the elements. So compared to the bubble sort, it is easy to arrange all the elements in sorting order quickly. So the basic concept of merge sort is divides the list into two smaller sublists of approximately equal size. Recursively repeat this procedure till only one element is left in the sublist. After this, various sorted sublists are merged to form sorted parent list. This process goes on recursively till the original sorted list arrived. So algorithm for merge sort is based on divide and conquer. Its worst case running time has a lower order of growth than insertion sort. Since we are deal with subproblems, we state each subproblem as sorting a subarray. So the basic rule to do merge sort is we have to divide the elements. After that we have to conquer. At last we have to combine all the elements. Now let us take a small example and implement this merge sort technique. Okay. Okay, now I am taking some elements So 43, 61, 37, 52, 17 and 27. So here I took 6 elements. So I stored these elements in array. So that's why I am giving here index size also. So to sort the elements, we have to divide the elements first. So to divide the elements, we have to find the low, high value and mid value. So the low value is here 0. So we have to check the low value as per index, not as per values. Okay, so here high value is 5, and now we have to find the mid value. So mid value is lower value plus higher value divided by 2, that means 2.5. So we already know that we have to use floor value only, that means 2. So the mid value is 2. So here it is the mid value. Now we have to split, that means here we have one array. So in this particular array I stored 6 elements. Now here I am dividing these values with the help of mid value, that means 43, 61, 37. This is one array, and these 3 elements comes under another array, and the same index values are same. Now again we have to divide these elements. So here also we have to find the mid value. So for this particular array, 0 is the lowest value, 2 is the highest value, and we have to find the mid, that means 0 plus 2 divided by 2, that means 1 is the mid value. So here 61 will be the mid value, and here low value is 3, high value is 5, and mid value 3 plus 5, that means 8. So 4 will become the mid value. So again we have to split here, that means 43, 61 comes in one array, 37 will comes to another array, and 52, 17 will comes to one array, and 27 will comes to another array. Again we have to so these are the index values. Okay, now again we have to find the mid value for these particular elements. So here L is 0, high is 1, and mid is 0 plus 1 divided by 2, that means 0 point something will come, and we have to use floor value here. So 0. So here 43 will come in 1, 37, 52, 17, 27. So in this way we have to divide all the elements. Okay, now we have to do comparison for each and every element. So first we have to do comparison for these 2 elements. So 43 greater than 61. So here condition is satisfied. So here 43 is small, compared to 43, 61 is the largest element. Now we have to combine each and every element. So in this way, and 37 will remain constant. Now let us do these 2 elements. So 52 and 71. So compared to these 2 things, 17 is the smallest. So here we have to swap. After swapping 71, 52. So 27. Now imagine these particular 2 elements in I loop, then this is J loop, this is I loop, and this is J loop. Now we have to run the loop, and we have to do comparison this particular 37 to 43 and 61. Now let us compare 37 and 43. So compare it to these two elements. 37 is the smallest element. So compare it to 61 also. 37 is the smallest. So after that 43 and 61. So in this way the elements will be arranged. Now let us compare these things. So compare it to 27, 17 is the smallest. Compare it to the 52, 27 is the smallest. And 52 remains constant. Now let us imagine this particular array is I loop and this thing is J loop. Here also we have to do comparison with each and every one. So compare it to 17 and 37. 17 is the smallest element. So compare it to 27 and 37. So in this way we are using looping. So first element and second element first element. So compare it to 27. 37 is the largest, so 27. Now we have to do comparison 52. Here 52 is the largest element. Okay, this thing is finished. And again 43, 17. So 17 is small, already we placed it. 27 is small, already we placed it. And 52 also small, already. Okay, here 37 we left. So 52 is the largest, so 43 will remain constant. And again 61 with 17. So we already placed it, 27 and 52. So compare it to 61, 52 is small. So that's why we placed it first. At last 61. So now the sorting technique is completed. So by using merge sort we have to implement in this way. So first of all we have to find the mid value, low value and high value. With the help of these mid values we have to split all the array elements. So after splitting all the array elements we have to do comparison each and every element. So after comparison we have to combine all the elements. So at last all elements will be combined and sorting also happen here. I think you understand this topic. Thank you.